Hi everyone, in this video we're doing section 2.3 from your textbook. And section 2.3 is kind of a recap of section 2.1 and 2.2 with really an emphasis on being able to recognize really bad data visuals and recognize what makes those data visuals misleading. So sometimes we use data visuals, I think, to be intentionally misleading in some cases. If you have a particular agenda you're trying to push, or if you're trying to sell something like in a commercial. And we'll see some of that maybe in a moment. But first, I want to just remind you of the goal of data visualization. And these are just a few things off the top of my head, so maybe you can think of some other goals as well. But you want someone to be able to briefly glance at your data visual and get the correct unbiased impression. And so data visual is just an umbrella term. It means bar chart, pie graph, histogram, time series data trend, anything that you're using to visualize the data. That's what I mean by data visual. And what I mean by an unbiased impression is you're not trying to do any tricks with your visual to sort of mislead your audience. Another goal of a good data visual is that someone who's looking for details can find them. And so it would be nice if your data that has some kind of unit of measurement has also an indication of what unit of measurement that is, right? And so what I mean is if your horizontal axis means time since the start of some experiment, you specify whether you're talking about seconds or minutes or hours or days or years and so on. And if your vertical axis has something like weight, then you need to specify, are we talking about grams or kilograms or pounds or tons maybe? So specify exactly what your unit of measurements are. That's what I mean by someone who's looking for details can actually find those details. And then lastly, this is at the risk of restating myself, definitely don't use data visuals to lie. And also, try not to mislead your audience as well. Try to give them an unbiased impression of the data. So, here's my first example for you guys. The title of this graph is Cookout Calories. And so maybe you can glean from this that we're looking at 5 different items that you might find at a cookout and their calorie content. And it says beer, soda, chips, hot dog, burger. And we have different bars. And the way this is set up, it sort of insinuates that the height of the bar corresponds to, the number of calories, or at least the height of the bar should be proportional to the amount of calories. So like the taller the bar, the more calories. And we can see that burger has the most calories and it has the tallest bar, and beer has the fewest calories and so has the shortest bar. But the issue with this graph, the big glaring issue is this, that here, this little amount of height represents 140 calories. And what looks like pretty much the same additional height when we look at the soda bar is actually only 10 calories, because that represents the difference between 140 and 150. And then here we see about the same height used to represent a difference of 50 calories. And maybe you see where I'm going with this, but here it again represents 150 calories. And then here, that same height difference seems to represent 350 calories. And so the issue I have with this bar graph, and the reason it's a very bad graph, is because when you present someone a bar chart, the underlying assumption is that the height of the bars is representative of the quantity that you're trying to represent. And here, the height of these bars is not proportional to the quantity we're trying to represent. And so it breaks our underlying assumption, and this is sort of misleading your reader. Because again, if you were to just take a look at the difference between beer and soda, it kind of looks like soda is, 2 times the calories of beer. Calories wise, it looks like this, since the soda bar is twice the size of the beer bar, you think well, soda must be twice as many calories, but in fact, that's not the truth. So this is misleading as a visual, even if they have the correct numbers there. Just some tips. If you want a really good graph, what you might add is some horizontal grid lines. So if you want a really good stuff to add to make this helpful, is probably horizontal grid lines and a labeled y-axis or a labeled vertical axis. That would have really helped us out here. As well as, of course, adjusting the height of the bars so that they're actually proportional to the number of calories of the item. Otherwise, pretty good. Okay, median salaries for females in the US. That's our next title of this bar chart here. And so what this is showing is, for every year, 2010, 2011, 2012, all the way up to 2017, I guess they conducted a survey of women in the US, asked what is your salary, and they reported just the median salary every year, and they have it represented like this. And again, the issue here is pretty much the same issue as I had with the previous bar graph, which is like, how tall is that and how tall is that, right? So let's call this height A and this height B. And it really looks to me like that height of B is like maybe, I don't know, that's like 2.5, so this is 5. This is actually appears to be, 3 times as tall as A. And so what that insinuates, again, as a graphic visual of our data, it seems like maybe in 2017, females got paid 3 times as much as compared to 2010, right? This is what we're sort of insinuating the way we've put together this visual, but in fact that's not true. If we actually squint closely at it, it looks like in 2010 they were paid about $36,500 as a median, and in 2017 they were paid about $41,500. And so this is clearly, this is not 3 times going from 36 to 41. It's actually only maybe a 10 or 15% change. But my point is that these bars really should be proportional to their actual values. If you're really trying not to mislead your audience with a bar graph, that's just best practice. And so if you see these on your homework, definitely that's one thing to look for, is think, are the bars in my bar graph actually proportional to the values they represent? Okay, this chart is titled Hourly Crime Rate Distribution. And so what this might be, if you're, let's say someone's trying to sell you a home protection system that has like security cameras, for example. And what they want to convince you is that maybe the hours while you're away from home, so maybe you're away from home from 12 noon to 6 p.m., they want to convince you that these hours away from home have the most crime. And they would like to convince you of that because a security camera is really no use to you if you're actually at home at the time. But, if you're away from home, maybe you want a security camera to keep an eye on all your stuff. So, again, if you're trying to sell security cameras, it's in your benefit to have people believe that the hours away from home has the most crimes. And so maybe this pops up in one of your brochures. You put this nice data visual together, and you say to homeowners, look, among all of these different time periods when people could commit crimes, it's most popular to commit crimes in the afternoon, from noon to 6 p.m., when you're away at work. So maybe you should buy our security cameras. My issue here with this graph is tricky to find, honestly. Like it maybe takes you a moment. Among the other things, this is actually the trickiest. Maybe the first thing you looked at based on our previous examples was the height of these bars. And you'll find that I actually do have horizontal grid lines. And so that's actually really nice. So good job with those horizontal grid lines. And we do have a y-axis that's labeled, right? And I'm sure these values have something to do with crime rate. And so that's actually really nice. It starts at 0, and so I can trust that these bars are actually representative of, they're actually proportional to the amount of crimes they represent. The big issue here, finally getting to the point here, the big problem with this bar graph is that this bucket is not the same width as the other buckets, right? So from 6 a.m. to 9 a.m., that represents 3 hours, and from 9 a.m. to 12 p.m., that represents 3 hours, and from 6 to 9, that's 3 hours, and from 9 to 12, 3 hours, 12 to 3, and 3 to 6, that's also 3 hours. But what about this bucket width? It's actually representing 6 hours. So, of course, it's no surprise when you finally recognize this. It's no surprise that this bar should be the tallest bar because it's actually representing 6 hours worth of opportunity for criminals to, commit burglary, for example. And you'd expect that bar to be twice as tall. But of course, this is not the right way to make a histogram. The correct way to make a histogram requires you to have the same width for each bucket. And this is my last example for you in this video. We have dog breeds at the dog park, and this is what you might call a 3D pie graph. So it's a pie graph just like you've seen before, just like we made in a previous video. But instead of a circle, you have this sort of cylinder shape. And maybe it looks neat, it looks modern, I don't know. Maybe there's some sort of appeal to the way this looks. Now my issue with this is that if you were to look at the size of these slices as it appears to you and estimate, the proportion of the slice that this takes up in your field of view, I'll just approximate this for you guys because, I'm trying to do my best to sort of guess this out. I'd say maybe this is like 25%. Based on how much blue I see and how much gray I see. This is probably something like, like 35%. And this orange bit is maybe, 20%, and the yellow bit is maybe 20%. And I don't know how much I have left actually to assign to these green and blue, but these are really little. And the way I created this on Microsoft Excel, I made this just a moment ago, so I still remember these things. The way I made this is I made it so that this blue slice was actually 45%, and these orange, gray, and yellow slices all represent 15%. So what I don't like is the 3D perspective. You can actually use the 3D perspective of a 3D pie graph to put, maybe the largest slice in the back where it doesn't look quite so big. And any slice that you want to emphasize or want to make bigger, you could just rotate that around so that it's in the front. Maybe if you're a huge fan of dachshunds, and convince people that dachshunds are the most popular dog breed, then you would want to rotate this gray dachshund slice to the front of the pie, and so on. So anyways, it's a good rule of thumb. It's a good practice to just say no to 3D, right? So even though it looks nicer, it's a little bit misleading to use these 3D pie graphs. Just use the 2D pie graph instead. All right.